Now we will discuss the concept of instantaneous velocity. As a name implies, we simply state it is the velocity of a particle at an instant. Practically it is very difficult to measure the velocity at an instant. Say, if a particle is moving in a particular directions, say in the direction of positive x-axis, at a particular instant of time it is at position x. So we consider a very small neighborhood of this displacement or this motion, say from time t to be considered the time t to t plus dt, and say in this small duration of dt it has traveled by distance dx. So it will be able to reach the position from x to x plus dx. So we can consider that at the instant t, the particle has covered distance dx in time, dt, so at this time t or at the instant t, instantaneous velocity can be given as this, given as v is equals dx by dt. As it is velocity, we defined it in vector form. V vector can be written as dx vector, which is in this direction, divided by dt. So you can simply state it is the rate of change of position with respect to time. This is giving us the instantaneous velocity. Or we can simply write we are having the position as a function of time. We can find out the differentiation of position with respect to time to get the value of instantaneous velocity. So we can also write the instantaneous velocity is differentiation of position with respect to time. Or we can also write, for a given motion, if position is defined as position x is given as a function of time, then instantaneous velocity is the slope of x versus time curve. As we already studied that this differentiation of a particular variable with respect to its free variable on which it depends, it gives us the slope. Or, if y is given as f of x, we have studied that dy by dx is the slope of y equals fx curve. Similarly here we can write we are having position as a function of time. Then instantaneous velocity is given by the slope of x versus time curve. In this example, we are asked that if a particle moves such that its displacement is given as 4t to the power 4 minus 3t square plus 7t plus 6, we are required to find the velocity at t equals 2 seconds. So here the question is almost directly handled just by differentiating the displacement with respect to time, as we know v equals dx by dt. On differentiating we get 16t cubed minus 6t plus 7. And we require to find the velocity at 2 seconds. We can directly put the value of t at 2. This will be 16 into 8 minus 6 into 2 plus 7. So this will be 128 minus 12 plus 7, that is equals 123 meters per second. So you just keep it in mind directly that on differentiating the displacement with respect to time we get the velocity. You can also write down a note, which gives you relation in velocity and displacement as differentiation of displacement is velocity. On integrating velocity we get displacement We'll also take some application based on this. As far as such questions are concerned where you are just given with the displacement, you are required to find the velocity. You just need to simply differentiate it and substitute the value of time when you required to calculate the velocity.